Hi dear students, welcome to another session of important question discussion from your grade 11 chapter, Organic Chemistry, some basic principles, right? Hydrocarbons, the chapter we already discussed. Now we are dealing with the organic chapter. Organic chapter, what all type of question you can expect from the beginning part, the basic part. What all questions we can expect here all for your upcoming examination. Nomenclature questions, right? Write the IUPAC name of a given compound. Maybe they give you the structure, write the IUPAC name, or opposite, like they will give you the name of the compound. We have to write the structure of the compound. And there are three representation of an organic compound: the bond line formula, the expanded formula, the condensed formula, that the different forms they can ask you to write it. Then another question we can surely expect from the isomerism part. You may study structural and stereo, especially structural isomerism in this chapter is very important. Stereo isomerism we actually discussed in hydrocarbons detail, right? Cis trans isomerism. And then we can expect the questions like what is meant by homolytic fission and heterolytic fission. So, and the resonance structure, it means resonance effect, inductive effect, electromeric effect, hyperconjugation, stability of carbocation. These all are very important topic. What are nucleophile, electrophile, all we can discuss in detail with the most important question in this discussion. Hope you all are ready. Let us start from the first question, which include NCERT questions, some repeated question for your school exam. Okay, let's start. Question number 1. How many sigma and pi bonds present in the following compound? You know that sigma pi bond, what's the calculation? But whenever you answering sigma bond and pi bond calculation, it's compulsory to know that expanded form. We have to write the complete expanded form of the compound, then only we can able to find the full amount of sigma bond and pi bond. Okay, let us start. So question 1 is from the compound is, let me just expand, it's given as CH, right? CH, triple bond C, single bond C, triple bond C, and then CH3. This is the complete expanded form of the compound, right? You know very well, each single bonds are sigma. In a double bond, 1 sigma, 1 pi. In a triple bond, 1 sigma and 2 pi. Yes or no? Correct, right? So let us find, this is sigma, pi, pi, this is sigma, pi, pi, sigma, right? All are sigma. So 1, 2, 3, 4, 5, 6, 7, 8. There is 8 sigma bond and 1, 2, 3, 4. There is around 4 pi bond. Correct or not, dear? So all the structure, okay, all the each and every bond we have to expand. Okay, CH triple bond C, single bond C, triple bond C, CH3. 1, 2, once again, 1, 2, 3, 4, 5, 6, 7, 8 sigma bond, 1, 2, 3, 4 pi bond. What about this one? This is CH2, right? What is CH2? This one. CH2 double bond, C, double bond, CH, C, CH3, right? This is CH3, correct. How many sigma bonds are there? Let us count. Number 1, 2, 3, 4, 5, 6, 7, 8, 9. There is around 9 sigma bond. How many pi bond? 1, 2, right? Only 2 pi bonds are there. So only the point, keep in mind, whenever you saying or asking, they ask you to calculate the number of sigma bond and pi bond, please expand each and every bond, including carbon, hydrogen, carbon, carbon, all bond we should expand. Clear? Next question, dear all. Write the bond line formula. You know, bond line formula we will express only with the bonds, right? Only bonds. Write the bond line formula for the compound. This compound is actually given as C triple bond N, right? So let me write C triple bond N. Right, carbon CN bond. Then there is a CH carbon. We can write like we can write any up or down, anywhere we can place it, no issue. This is C and this is CH carbon, on which one OH group is there. This is another C and on which what triple bond N is there, right? Or we can express this one triple bond N, then OH, triple bond N, right? What is its meaning actually? This nitrogen already there, you know, heteroatom, right? I like oxygen, nitrogen, some heteroatom if it present, we have to specifically mention that, okay? So this is nitrogen, this gap indicate there is a carbon. What is this carbon? C. Already 1, 2, 3 valency completed. So this is a CH carbon. This is also one gap where one carbon should be there. So this is the compound CN, CH, OH, CN. Right? This is the bond line representation of the compound. This one. So when you're writing bond line formula, if it is completely carbon chains, then no need to mention carbon separately. You know very well. For example, if you have the compound CH3, 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 how can we write the bond line formula? You know, in the major chain contain 3 carbon, right? So let me write 1, 2, 3. 1, 2, 3 carbon. On the first carbon, there is a methyl group. Yes, on the first carbon there is a methyl group. If there is any hetero species when comes, for example, you have CH3, CHOH, CH3. If it is coming like this one, take the parent chain 1, 2, 3, 1, 2, 3. On second carbon there is a OH. We have to specifically mention that. That's only the difference in bond line representation. Clear on? Next question. What is the cause of geometrical isomerisms in alkene? Actually, we discussed in detail in the chapter hydrocarbon regarding geometrical isomerism. You know, geometrical isomerism means cis-trans isomerism. It is given by only alkene, that is because of the restricted rotation about carbon-carbon double bond. You know, cis and trans while you drawing, you know, suppose this is A, B, B. This is called, you know, cis form. Same group on same side, what we call cis form. You know, why cis-trans isomerism given by alkene mean? That is due to the restricted rotation. See, the carbon-carbon double bonds are not rotatable due to the restricted rotation. Because of the groups changes and all, we will say cis and trans. If A same side, cis. If A opposite side, what we call trans. So keep in mind, alkene has a pi bond and the restricted rotation around the pi bond gives rise to geometrical isomerism. Okay, this is a reasoning question we can expect. Next one. Name the chain isomers of C5H12. What is C5H12? You know that pentane. It can be pentane, right? It can be pentane, C5H12, which has a tertiary carbon atom. You know, write the chain isomer. What do you mean by chain isomer? Compounds having same molecular formula but different carbon chains, different carbon skeleton. This is called what? Chain isomerism. Same formula but different carbon chain. You may study that for pentane, total 3 chain isomers are there. What are they? You can able to say one is normal pentane, right? One is normal pentane. This is called N-pentane, normal pentane, right? C5H12. Now let me place one carbon as a branch. I can write it CH3, CH3. Then we have CH2, CH3. What is the IUPAC name of this compound? 1, 2, 3, 4. 2-methyl butane, right? 2-methyl butane is the compound. What is one more possible, you know, one carbon attached to 4-methyl group. One carbon attached to 4-methyl group. What we call for this one? 2,2-dimethyl. 2,2-dimethyl propane. 2,2-dimethyl propane. Question. Which of the following isomer of pentane can possess or it can give a tertiary or it contain tertiary carbon atom? What do you mean by tertiary carbon atom? If you consider this carbon, if it connected to only one carbon, now the carbon is primary. If this carbon connected to 2 carbon directly, it is secondary. If a carbon connected to 3 carbon, then it is called what? Tertiary. If the carbon connected to 4 nearest carbon, it's quaternary. See, dear all, where you can able to see there is a tertiary carbon atom. Can you guess it, dear all? That's no doubt second option, right? All of you just observe this carbon. This carbon attached to 1, 2, 3. Yes, it's having a tertiary. Do you think about this third one? No, the third one, this carbon connected to 1, 2, 3, 4. It's quaternary, dear all. What about this case? This carbon connected to 1 primary. This carbon connected to 2 carbon secondary. It connected to 2 carbon secondary, 2 carbon secondary, but this is primary. So, if you're checking 1 carbon primary, secondary or tertiary, just check this carbon directly connected to how many carbon. So, this is the only. So, what is answer? 2-methyl butane contain 1 tertiary carbon atom of which one? Isomer of pentane. Okay, so answer is 2-methyl butane. Next one. Define homolytic and heterolytic cleavage or fission. Homolytic and heterolytic cleavage. What is the cleavage in the sense? What? Fission. Homolytic fission and heterolytic fission. What it is? Let us discuss with a simple example. You consider about a species like chlorine single bond Cl. Means Cl2 molecule you consider. Cl bond is there. You know, one bond is equal to 2 electron. One bonds contain 2 electron. Both are same element and their electronegativity same. Right? Both of them are same element and their electronegativities are same. Since there is no change in electronegativity, how the bond can break, dear all? Both of them are having same electronegativity, means one electron goes to one species, the other electron goes to other species. We can express like this. And have you noticed the arrow representation? This is the arrow represent movement of one electron and the normal arrow represent movement of 2 electron. This is called fish hook arrow representation. It's just like our fish hook, right? This is called fish hook arrow representation. It's indicate the movement of just 1 electron. Keep in mind. So 1 electron goes to Cl, 1 electron goes to Cl. You will get Cl dot, Cl dot. You know the dot, odd electron species, what we call free radicals. So, during why it's called a homolytic fission? Because they are equally distributing the electron. One electron goes to left, one electron goes to right and represented by fish hook. Okay, keep in mind. So, homolytic cleavage represent the breaking of a covalently bonded species and the equal distribution of electrons to each element. That is called what? Homolytic cleavage, and it's bring free radicals intermediate. What about a heterolytic cleavage? Let me tell you one example. Let us consider CH3Cl. See, CH3Cl means this bond having 2 electrons and the 2 electrons are directly connected to carbon and chlorine. Check. Both side different species. Which is most electronegative element? Carbon or chlorine is more electronegative. You know very well chlorine is more electronegative than carbon. So both of the electron goes to chlorine. Both of the electron goes to chlorine. What you will get? CH3 plus, because CH3 losing, chlorine gaining. CH3 plus, Cl minus. You will get a cation and an anion. So keep in mind, all of you, if it is a homolytic fission, you will get free radical. If it is a heterolytic fission, you will get one cation and one anion. So here equally distributing electron, that's homolytic. Here unequally distributing electron, that's called heterolytic cleavage. Clear, all of you? The bond breaking is keep in mind. Next one. What are electrophiles and nucleophiles? Very important question. What are nucleophiles and electrophile? Carefully study all. Nucleophiles are nucleus loving species. The one which attract a nucleus. You know, nucleus charge is positive. Nucleus charge is positive. So what is the charge of a nucleophile? It can be negative. Can be, right? So nucleus loving species are called nucleophile. Electron loving species are called, you know, what is the charge of electron? Negative. Electron charge is what? Negative. So nucleophiles are, it can be negative charge or neutral charge. Okay. Nucleophile can be negative charge or neutral charge, and they are electron rich. Therefore, they are going to attract a nucleus. Try to understand. Nucleus is positive charge. So, nucleophile charge can be either negative or neutral. They are electron rich compound. They are electron rich. What are electrophile? They are electron attracting species. Why they are attracting electron? Because they are electron deficient. So, charge can be positive or neutral. Okay, positive or neutral. Now, how can we identify whether the given species is a nucleophile or electrophile? Simple. They are all generally, okay, I am saying the general trend. Generally, nucleophiles having a lone pair or negative charge. Okay, it's a basic idea to identify whether it is a nucleophile or not. Nucleophiles having basically a negative charge or a neutral charge. So, negative charge or lone pair should be present. Okay, negative charge or lone pair. Whereas electrophiles mean electron attracting species, they mostly contain positive charge. Even there also neutral charge is there. I will give you some example. So generally, nucleophiles are nucleus attracting species, electrophiles are electron attracting species. Nucleus, why they attracting nucleus mean they are electron rich. Electrophile, why they attracting electron mean they are electron deficient. Alright, nucleophiles general charge is negative or having a lone pair, so it's contain lone pair, whereas electrophile general charge is what? Positive one, or they are electron deficient, correct? So let me show you with some example, not at all. Classify the following into electrophiles and nucleophiles. First they given NH3. You know, NH3 nitrogen contain a lone pair. BF3, let me just draw like this one. You know, this is called a BF3. Next one H2O. Yes, H2O oxygen contain lone pair, you know. And FeCl3, let me write FeCl3, okay, RF1, FeCl3. And OH minus and H3O plus. These are the species I am giving to you. Can you tell me which of them are electrophiles, which of them are nucleophile? Dear all, are you ready? Let's start. NH3, you know, it's having a lone pair. Lone pair means electron rich. Electron rich mean definitely they attract a nucleus. So yes, NH3 is a nucleophile. So let me take H2O also. Yes, H2O contain lone pair. So the lone pair can donate, they are electron rich. So that is also a nucleophile. And let me write negative charge. As I told you, negatively charged species also can attract a nucleus. They are a nucleophile. So nucleophile basically contain either lone pair or negative charge. Not always, okay. Let me tell you from the example detail. What about BF3? Carefully listen all. BF3, FeCl3 and all listen. Can I take H3O plus as an electrophile? Yes, of course, because H3O plus having a positive charge, definitely it attracts an electron, correct? H3O plus is electrophile. Only confusion with BF3 and FeCl3. Carefully. Check it all of you, the central atom, boron and iron. The boron having only 3 bonds. You know, 3 bonds contain how many electrons? 1, 2, 3, 4, 5, 6. It contains only 6 electrons. You know, 6 electrons mean they are electron deficient. Why they are electron deficient? They didn't complete the octet. They need 2 more electrons to complete octet. Am I right? Same situation. Fe having 3 bond means 6 electron. They are electron deficient. Electron deficient species, what can they do? You know, electron deficient species try to attract electron. So they are electrophile. So BF3 is an electrophile. Even FeCl3 also an electrophile. Okay, keep in mind all of you. Both are electrophile. BCl3 and FeCl3 both are what? Electrophile. So generally, let me give you one more example from NCERT question. Giving justification, categorize the following as nucleophiles or electrophiles. They are all, first one is given HS minus. The other one is given BF3. Just I discussed now BF3. Now C2H5O minus. Then CH3 thrice N with a lone pair. Then Cl plus. The other cases like CH3CO plus and H2N lone pair minus and NO2 plus. Let us see dear all. Minus charge is there. Minus mean electron rich. They will attract a electron. Means they are electron rich. So they will attract a nucleus. Negatively charged species what? Nucleophile. Negatively charged species nucleophile. And here also negative charge and lone pair nucleophile. Okay. Now, lone pair species also nucleophile. Yes, see, this is a lone pair nucleophile. And okay, done. And positively charged species are what? Electrophile. So Cl plus is an electrophile. This plus is there, electrophile. The NO2 plus electrophile. Okay. What is left? BF3 case I already told you. BF3 central atom is boron. It do not completed octet. They are electron deficient. So they will try to attract electron. So they are what? They are also electrophile. Clear all of you? So basically from our NCERT point of view, we can able to say negative part, negative charge or lone pair if there, they are considered as what? Nucleophile, because they are generally electron rich. Okay, electrophiles mean they are electron deficient compound, so they generally having a positive charge, or you can able to see BF3 like a species are electron deficient, so they will definitely try to attract electron, so they are treated as what? Electrophiles. Hope it's clear, dear all. Let's go to the next one. Define inductive effect, or you may study what is mean by I effect. Define inductive effect. You may study that one, right? Anyway, let's discuss. It's a sure question for your exam. Let me consider a carbon chain, a saturated carbon chain. Let me consider with a electron donating group. Okay, with an electron donating group. One another saturated carbon chain like alkane. Let me take it with a EWG. What is EWG? Electron withdrawing group. This is electron donating group. This is electron withdrawing group. Okay. Let me give you a general list of electron donating and withdrawing group. Okay. In general electron donating groups are OH, alcohols, they are electron donating. Sorry, alcohol is electron donating. Amines are electron donating. You know, R means what? Any alkyl groups like methyl, ethyl, propyl, any alkyl groups are electron donating. OR, what is OR? Alkoxy, methoxy, ethoxy. Like alkoxy groups also what? Electron donating group. So which all are basic electron donating? Many are there. Okay, basics I am saying. Alcohol is donating group, amine is donating group, alkyl groups are donating group, alkoxy groups are donating group. Many are there. Electron withdrawing groups, which all? Electron withdrawing groups, you know, nitro group is very strong electron withdrawing group. Cyanide is withdrawing group, acid is withdrawing group, aldehyde is withdrawing group, ketone is withdrawing group, even halogens also normal chain will electron withdrawing group. So these suppose if there is an electron donating group present on the saturated chain, what going to happen? What going to happen, dear all? This electron donating, see dear all, very simple. This electron donating group will donate electron to the chain. Of course, right? When it donate electron, it will get a partial positive charge. What is the symbol represent? Small delta, which indicates a small positive charge. Why getting positive charge? Because it's donating to what? This carbon. So it will get a negative charge because this electron donating group donating, this carbon gaining. Yes. Now this bond is what? Polar. Now the bond is polar. Why it is? What do you mean by polarity? There is a charge separation. There is a charge separation. Why this charge separation generated? Because of the change in their electronegativity. One is donating, one is gaining. Correct? So now this polarity won't stop there. It is transfer or it induced to the next carbon-carbon bond and it's going on. This is called what? Inductive effect. So, see, even this carbon also very close to this electron donating group, it also get charged. It is delta, delta minus. What about this one? Delta, delta, delta minus. You don't think, please, this is bigger like that. No, these are two smaller. So because this donating group is very close to this carbon, so this effect, this polarity is more. This is most, it's least, very least. Means as the distance from the group, increases, this effect slowly decreases. What about the charge? You can able to guess here. EWG means they will withdraw the electron from the chain. So they will take electron, so it will get negative charge. So what is the charge here? Positive charge. Now it is polar. This polarity transfer to the nearest bond. So what you will get? Delta, delta plus, delta, delta, delta plus, like that. So as the distance from the group increases, this effect diminishes. This will be smaller. And one more thing, you know, inductive effect is called I effect. There are two type I effect, plus I effect and minus I effect. If donating groups present on the chain, then it is called plus I effect. So these all are what? Plus I effect group. If electron withdrawing group present, it's called what? Minus I effect. So these all are minus I effect groups. Okay, so the polarization of a sigma bond, depolarization means the charge separation. Okay, polarization of a sigma bond due to the electron withdrawing or electron donating effect of adjacent group or atom is called what? Inductive effect or I effect. Simply we can say, due to the change in electronegativity, one of the bond initially get polarity that transfer or induce to the next CC bond and it's going on. This process is called what? Inductive effect. If it is electron donating group present on a saturated chain, it's called a plus I effect. If there is an electron withdrawing group present, It's called a minus I effect. Clear all of you? So study which all are plus I effect and minus I effect group. Let me show you one NCERT question. In which carbon-carbon bond of the compound CH3, CH2, CH2, Br, the inductive effect is expected to be the least? Dear all, here which is the group present? Bromine. Halogens, you know, generally electron withdrawing group, right? Generally halogens are electron withdrawing group. So they will get negative charge because they are taking. So it will get positive charge. So it will get delta, delta plus, delta, delta, delta plus. Which carbon-carbon having least inductive effect? Can you tell me, dear all? You know, as the distance from the group increases, this effect decreases. So here is the weakest inductive effect. We can say CH3, CH2 bond, where this carbon-carbon bond, the effect is very least because it's far away from the group attached. Clear all? Next question. Write the expanded form of the following condensed formula. You know, these are our condensed formula, right? Condensed mean short form. Write the expanded formula. What do you mean by expanded formula? Write the complete bonds. Each and every bond expanded. So let us write, all of you, don't worry, listen carefully. What do you mean by CH3? CH3 we can write like a CH3, right? 3 hydrogen. Then it's connected to CH2. CH2 mean carbon connected to 2 hydrogen. Then C, you know, carbon oxygen, what? A double bond. You can write up or down, doesn't matter. Carbon oxygen, you know, always make what? Double bond. Then continue CH2. Then continue CH3. Keep in mind, all of you, this is organic chemistry, all carbon. Each carbon, the valency should be 4, which means on each carbon, 4 bonds should be there. It should not be less than 4, more than 4. What about this case? CH3, we can draw like this one. Sorry, CH3, CH, right? CH. You can write up, down, doesn't matter. Bonding should be correct. Continue, double bond, C, on which one hydrogen. What do you mean by CH2 thrice? There are 3 CH2 group, correct? Okay, let us write one CH2, another CH2, third CH2. And finally, what you have? One CH3. This is the expanded form of the given compound. Clear, all of you? So when they given condensed formula, when you make into the expanded form, write each and every bond in most expanded. Even carbon-carbon bond and carbon-hydrogen bond. Okay? Clear, all of you? Next one. Write the structural formula of. See, here they given the name. You want to draw the structure. What do you mean by P para? You hope you remember what is ortho, meta, para positions on the benzene ring if there is a group present, right? Para nitro aniline. So which is the main group here? Aniline. What is aniline? Benzene with NH2. Yes, I hope you already said that structure in your mind, or imagine that structure in your mind. Aniline means benzene with NH2. If aniline is here, this is the ortho, this is the meta, and this is the para. Where para position, there is a nitro group, right? This is called para nitro aniline. Clear all? Next one. 2,3-dibromo. What is the meaning? Second and third position bromine are there. One phenyl, first position phenyl ring is there on what? Pentane. What do you mean by pentane? Pentane means 5 carbon. 1, 2, 3, 4, 5. Immediately don't write CH3, CH2, etc. Okay. Make the parent chain first. 5 carbons we place. Okay. Second and third position 2 bromine. Second and third position 2 bromine. Okay, perfect. First position phenyl. First position what? There is a phenyl ring, you know, benzene ring, phenyl ring. And complete the valency. This is CH2, CH, CH, CH2, CH3. That's it. So this is the compound here all. 1, 2, 3, 4, 5. 2, 3 dibromo, 1 phenyl, pentane. So dear all, it's an organic chemistry. Very carefully write the valency of the carbon. Okay, or carbon, all valency should be 4. Okay, clear. Next one. Draw the 2 geometrical isomer. You know, geometrical isomer mean cis-trans isomerism, right? Write the 2 geometrical isomers of but2-ene 1,4-dioic acid. Let me draw its structure first. But, what do you mean by but? 4 carbon, right? But means 4 carbon. Second position alkene, so 2-ene. First and fourth are dioic acid. First and last carbon is carboxylic acid. So this is CH, this is CH, right? This is the structure called but-2-ene-1,4-dioic acid. Let me write what is a cis form. You know, cis form means we will draw this one first. Which is this 2 carbon? These are the 2 double bonded carbon. Can you tell me what all groups are on this carbon? One hydrogen is there, one COH is there. Let me place one H and COOH, right? Next, even the other carbon also having one hydrogen and one COOH. Yes, we place. So this is cis form. You know, same group are on same side. What is the trans form of the same structure, dear all? Trans form is very simple. Make one position as it is, the other side just interchange. Yes, here same group on opposite. Okay, perfect. Now the question, we draw the structure. Okay, cis and trans we draw. Next. So this is cis. This is cis and this is what? Trans. Done. Perfect. Next. Which of the following having highest dipole moment? You may studied cis is almost having highest dipole moment, right? Let's see. Why it is so? You know, acid COOH is actually what? It's an electron withdrawing group. It's an electron withdrawing group. Acids are what? Generally electron withdrawing group. So when they withdraw electron, see they are pulling this way. So resultant is what? Downward. There is a resultant, right? So therefore it's having a high dipole moment nu. It's having a dipole moment. So what is the compound said to be? Highly polar, right? So they're having high dipole moment because both of the COH group are, you know, COH group is a withdrawing group. So they pull the electron down. So resultant is downward. What the case in the case of transform? You know, acid, if this acid pulling in this direction, this acid pull this direction. See, they two same species pulling with same strength from opposite direction. What happened? They got cancel each other. So the compound, the dipole moment is 0. No dipole moment, or it's very less. No nu means what? Dipole moment, right? And one more thing, dear all, very careful. Why we are not dealing with the carbon and hydrogen? Carbon and hydrogen almost similar electronegativity, so no need to bother about its effect. Okay, so acid is the only one main electron withdrawing group here. So we draw the cis and trans form and we explain which one having highest dipole moment. Cis. Clear all of you? Yes, let's go. Which of the following shows geometrical isomerism? Which of the following can give cis trans? Let's see. First you draw this one, C double bond C, C double bond C, C double bond C. This one you place first. Now attach the groups. On C, dear all, these are the C double bond C carbon. In the left carbon, one hydrogen and one chlorine is there. On the right carbon also one hydrogen, one chlorine is there. In this case, these are the C double bond C carbon. Left side 2 hydrogen, right side 2 chlorine. Here, these are the C double bond C carbon, left side 2 chlorine, right side 1 H and 1 Cl. Let's discuss, dear all, careful. Can you say which of the following shows geometrical isomerism, cis trans? What is a simple question? Whether this one can show or not. Dear all, if it is a cis, you should have another structure for trans also. Okay, cis and trans do not occur in the same one. See this hydrogen, hydrogen, same side, chlorine, chlorine, same side. Yes, it can show cis isomer. If you just interchange these two, you will get a trans also. It can show. What about the B question? See hydrogen, hydrogen, chlorine, chlorine. Can it show? No. Why? Dear all, the minimum condition to show the cis trans is the carbon-carbon double bond, right? Carbon-carbon double bond. On both of these double bonded carbon, at least one group should be common. Here, on one carbon, both of them are same. Not like that. Both of these 2 carbon, one group should be common. See here 2 carbon, hydrogen, hydrogen common. So here one carbon having common group, it is not possible. So not cis trans isomerism. What about this case? Dear all, it cannot show. It cannot show. Why? See, you may think this chlorine are opposite, right? Sir, it's a transform. Yes, right? Even you consider this Cl also. If this Cl when you consider, that is cis isomer. Correct or not? So cis and trans do not occur in same. Or you remember, out of this 4 group, any 3 are repeated. Any 3 are repeated, it do not show cis trans isomerism. Clear? So this is the one shows cis trans isomerism in this question. Next question, dear all. how many how many isomers are possible for mono-substituted? What do you mean by mono-substituted? Only one group. And di-substituted benzene. Okay, how many isomers are possible? Let's see. Let me take benzene first. Suppose I am going to place any group. They didn't mention which is group. Let me put chlorine. Okay, let me put chlorine. I am going to substitute chlorine. Where you can place chlorine? I think I can place one chlorine here. You can call chlorobenzene. Even if you place here also, it's chlorobenzene. Any other 6 carbon, if you place one chlorine, it will be chlorobenzene. So mono substituted. This is mono substituted because it contains only one group substituted chlorine. So for benzene, you can get only one product, right? You will get only one mono substituted product. Only one mono substituted product. You will get only one product. If you put chlorine on any other carbon, you will get the same product. What about di-substituted? They are di-substituted mean something different. One chlorine here, one chlorine here. What is the name of this compound? 1,2-dichlorobenzene. This is one structure possible. Here some other structure also possible. What? Can we place chlorine on this side? Yes. We can place one chlorine up, one chlorine on the meta position. This is 1,3-dichlorobenzene. We have one more arrangement. We can place one chlorine up, one chlorine down, 1,4 or para product. So total 2 substituted, how many products we can get in? Total 3 products we can get it. Okay, 3 products. Clear all of you? We'll get 3 products. Okay, so mono substituted product is only one from benzene, whereas di-substituted there are total 3. Next one. Next one. Okay. Define electromeric effect. We studied as what is E effect, capital E. What do you mean by electromeric effect? Definition is already there. Let me tell you the 2 cases. You know, inductive effect we studied as plus I and minus I. Similarly, electromeric effect is there, plus E effect and minus E effect. Carefully listen on, very simple question, very simple theory. Let me consider a double bonded compound. Okay, double bonded compound. It's an alkene. Even here also let me consider a double bonded compound. First, they are going to react with an electron. For example, let me add H plus. Here, let me add Cn minus. This is the attacking species. Okay, this is the attacking species. This is the attacking species in this question. Okay, carefully listen all. Carefully listen all. See a double bond. Normally, it is okay. Normally, it is exists like that. But when an attacking species comes, carefully listen all, when an attacking species comes to the double bond, when an attacking species comes to, I'm not saying the complete mechanism, only to understand. When an attacking species come to the double bond, just imagine the double bond shifted to one of the carbon. Either you can place it left or right. Okay, one double bond, one of the bond electron shifted to one carbon. So, you know, this electron shifted this carbon means this carbon will get a positive charge with this carbon negative because it's losing and this is gaining. Correct or not? Okay. Can you tell me where this attacking species can attack? Definitely it will go to negative charge because this attacking species charge is positive. H plus go to this carbon. What is the product? Can you tell me, dear all? You will get C to this new carbon, one hydrogen attack. The other carbon exists as positive charge. Yes or no? Same way, can you tell me the second product what happened? See, when an attacking species comes to the carbon, one bond shifted to one of the carbon, the left carbon get a positive charge, right carbon get a negative charge. Can you tell me where Cn minus attack? Here the attacking species charge is negative, it will go to definitely positive carbon. So we get Cn, C minus, correct? So what is the difference between these two structures, or what is happening in this one? This is called the electromeric effect. What is happening in electromeric effect? It is a complete transfer of electron. It is a complete transfer of electron of a multiple bond. Yes, the multiple bond, some electrons are moving, right? It's a complete transfer of electron of a multiple bond to one of the bonded atom in the presence of an attacking species is called what? Electromeric effect. Why it is called a plus E and minus E? Simple. See, dear all, to which carbon electron shifted? Second carbon. To which carbon attacking species attack second carbon? This is called plus C. So what it mean? To which carbon electron shifted to the same carbon attacking species attack, that is called plus C effect. So what is minus C effect? Here to which carbon electron shifted? Second carbon, but attacking species go to the opposite carbon. This is called the what? Minus C effect. Clear all of you? And notice that electromeric effect is a temporary effect because it is happen only in the presence of an attacking species. Otherwise this shift won't happen. Okay? So electromeric effect is a temporary effect, whereas our inductive effect is a permanent effect. We are not adding any attacking species in electromeric effect. Always their polarity will be there. Clear all? Okay, so inductive effect is permanent, electromeric effect is temporary. Clear all of you? Next. Define resonance effect. Define resonance effect. You know resonance, you may study resonance in detail, right? Resonance in simple word we can able to say it is the delocalization, complete delocalization of pi electron. You know benzene. In benzene there are 3 pi bond, right? In benzene there are 3 pi bond. What happened to this 3 pi bond? This pi bond can shift here, it can electron. It's actually pi bonds are not shifting, bond electrons are shifting. So when it's shifted like this, you may draw in another structure. Now the position of the double bonds are here. Correct or not? So this is called what? Resonance. The complete delocalization of the pi bonded electron are known as what? Resonance effect. Let me show you resonance in detail. You can take it as a reference, this definition. Let us write the question. They will ask you to they ask you to write the one of the resonance structure. Okay. Draw the resonance structure of phenol and nitrobenzene. What is phenol here all? Phenol mean benzene with OH, right? Phenol when benzene with what? OH. Detail and write exactly like this. This is phenol. Dear all, resonance while drawing, you know what are the things you have to be careful. Resonance while drawing, position of the element should not change. Electron number should not change. Only the pi bonded electron should move. Okay. Maybe lone pair become a pi bond become a lone pair. This is what happening in resonance. I told you already which all are electron donating group, which all are electron withdrawing group. Those who listen the class, can you tell me dear all? OH. Alcohol, OH where we studied, it's a donating group or withdrawing group? It's a donating group. You can see there is a lone pair, right? It can donate. So when it's a donating group present on benzene ring, how to draw the first resonance? Listen. This OH will donate electrons to benzene, right? This OH is a electron donating group. So they will donate electrons to benzene. So this lone pair becomes a bond. The pi bonds become a lone pair. Let me show you what is happening here. Carefully listen all. Sorry. First one. See, nothing happened to these 2 bonds, right? Okay. Now see, this lone pair become a bond. So it become a double bond. OH, this already there. Oxygen give electron, so it will get a positive charge. Yes or no? The one which you lose electron, it get positive charge. And this pi bond electron shifted to this one. You know, 1 bond equal to 2 electron. Yes, and this carbon gained electron, so it will get negative charge. So this is the first resonance structure of which one? Very sorry. This is the first resonance structure of which one? Phenol. Okay. What is second structure? Second structure, the lone pair becomes a bond and bond become a lone pair. This keep continuing. So dear all, the new pi bonds will be here and this upper sides, we are simply writing nothing happened to the upper side and the new electron reached here. Can you able to understand? What happened in the another structure dear all? In another structure, this lone pair becomes a bond and the bonds becomes a lone pair. We can write the new structure like this one, double bond, lone pair, and here what we have? OH, lone pair plus. Clear? And final structure, it will come back to our initial. How can we draw that? The lone pair become a bond, the bond go back to oxygen. We get our final structure as what? The double bonds and OH. So when you seeing the 5 resonance structure, what is the basic difference here? the pi bonded electrons, especially the double bonded electrons, are keep traveling through the ring, right? This is called what? Complete delocalization of pi electron. This is what we call resonance. And why it is happening mean resonance makes the compound more stable. More number of resonating structure mean more the stability of the compound. Okay, let me draw another compound. We have nitrobenzene. What is nitrobenzene? Benzene with the NO2 group, right? Let me draw the structure little expanded form. This is benzene, N double bond O, coordinate bond. You know, nitro group is exists like this one, N double bond O, coordinate bond O. You know, a double bonded oxygen carry 2 lone pair, single bonded oxygen carry 3 lone pair. Let me draw the resonance structure. You know that nitro group we studied under electron withdrawing group, right? Nitro group, this is EDG, this nitro group is EWG. So electron withdrawing group, if they're on benzene, they will take electron from benzene ring. What is the difference between this add to effect? Here electrons are giving to the benzene, here electrons are taken from benzene. So what is the first shift? This electron, you know, one bond equal to 2 electron, right? This bond shifted, this bonded electron shifted here, and this one shifted to oxygen. What all changes happened here all? Carefully listen all. Okay, these 2 pi bond, nothing happened, I think. All right, this carbon losing electron, so it will get plus charge. Here it become double bond, nitrogen. This oxygen, nothing happened. We are simply writing like that. And here the double bond becomes single bond, oxygen 1, 2, 3, and one bond also getting electron. So it get overall negative charge because this carbon losing, this oxygen gaining. So plus minus. Now what happened next structure is, here onwards only one shift you express. Here onwards the one shift only you have to write. Means this double bond go this side. This double bond, if it go this side, here it become double bond. Now new positive charge will be here. So dear all, nothing, no changes. Other all sides same. Here the upper part exactly copy like that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 negative. So this already there. Now this bond shifted here and new positive charge will be here. I hope you can able to guess the what is the next shift. This bond shifted here. So it will be new bonds here, plus charge here, upper side as it is. Alright, what happened in the last figure? Last figure they should get back their structure. So this lone pair back to their position. We will get nitrobenzene back. Only the double bond positions are differ. Clear all of you? These are the resonance structure we have to draw for nitrobenzene and phenol. One more thing, resonance effect is also called mesomeric effect, or resonance effect is also expressed by R effect. There are also 2 type R effect, plus R and minus R. This is what plus R effect, this is what minus R effect. What is the difference between them? In plus R effect, electrons are donating, or electron movement is taking towards the benzene ring because there is a donating group. Whereas in minus R effect, when an electron withdrawing group present, you see generally electron shift happen towards the group or away from the benzene ring. So here towards benzene ring, here away from benzene ring, the what happened? Electron movement is taking place. This is called what? Plus R and minus R difference. They all definitely they ask you to draw the resonance structure of any of the aromatic compounds like containing benzene. Okay, next one. Define hyperconjugation. Define hyperconjugation. Hyperconjugation mean it involves the delocalization of, means overlap between sigma electron of a carbon hydrogen bond of an alkyl group directly attached to. So let me take a one alkyl group, okay, CH3. This is one alkyl group and this is CH bond, okay, bond electron. This is going to overlap with what? Directly attached to a carbon atom, which is part of a unsaturated system. Maybe it's a part of an unsaturated system, means having a double bond, or has an empty p orbital, or either it should having a double bond or it should contain an empty p orbital. This overlap, what we call this delocalization, what we call hyperconjugation. So what do you mean by hyperconjugation, dear all? What do you mean by hyperconjugation? It is the delocalization of carbon hydrogen sigma electrons of a alkyl group with adjacent carbon, this is the adjacent carbon, having either double bond, either multiple bond, or it should contain a empty p orbital. This overlap is called what? Hyperconjugation. So definition wise they can ask the question. I will tell you where we want to apply hyperconjugation in one another question. See all of you. Explain why. Did all carbon carry positive charge? You may studied. They are called carbocation. Right? Carbon with a positive charge, what we call carbocation. Which carbocation is more stable? Let me tell you the entire idea. Carefully listen. Now it's a sure question for your exam. Stability of carbocation. Stability of carbocation. Let me explain detail. Listen carefully all. The order of stability is tertiary greater than, secondary greater than, primary greater than methyl carbocation. Let me take one example for tertiary. You know, tertiary mean the carbocation directly attached to 3 carbon. This is called tertiary. And another, if the carbocation directly attached to 2 carbon, then it is called secondary. If the carbocation directly attached to only 1 carbon, it's called a primary. And this is what? Just methyl carbocation. Okay, perfect. Listen carefully. Sorry. So this is tertiary, secondary, primary, methyl. Why the order of stability of carbocation like that? You can express, you can explain in 2 ways. Either by using inductive effect, I effect. Either by using inductive effect or by using hyperconjugation. Hyperconjugation, you can able to explain this point. Let me explain with a inductive effect. Okay, I effect. Dear all, this carbocation, you see carbon having positive charge. You know, carbon is an electronegative element, right? You know, carbon is in a non-metal. Non-metals are electronegative element. They are ready to take electron, right? Normally. So, electronegative element mean they prefer negative charge. Okay, electronegative element, you know, metals, you know, electropositive. For example, sodium charge is plus, magnesium charge is 2 plus, potassium charge is plus 1, calcium charge is 2 plus. They are metal, they prefer positive charge because they are losing electron. But non-metals are gaining electron, their charge is what? Negative, O2 minus, N3 minus, like that. So here you can able to see carbon carrying positive charge. You know, it's unstable, right? Carbon with a positive. Carbon is a non-metal, so it prefer negative charge. So positive charge on carbon is what actually unstable. So what kind of group is connected here? Alkyl groups, methyl, ethyl, right? Methyl. You know, alkyl groups I given that they are donating group. So this is a EDG, EDG, EDG. What about a secondary? Secondary carbo contain 2 EDG. Primary contain 1 EDG and this one no EDG. What is the problem with the EDG? You know, EDG means what? They will donate electron, right? They will donate. Electron donating groups mean they will donate electrons to carbon and it can decrease the positive charge. So more donating group, you know, electron donating group will show which effect? Plus I effect, right? Plus I effect. So more electron donating group mean more plus I effect. It make the positive charge on carbon, carbocation less. It make the stability more. So overall conclusion, more donating group when present on carbocation or more plus I effect group when present, that stability increases. This is the way we are explaining with what. But here what here all only 2 donating group, effect will be less. Here only 1 donating group, here no. So this is the one, that's why the order is coming like say tertiary, secondary, primary. Because of inductive effect you can explain like this. What about hyperconjugation? Dear all. Let me just expand the structure, okay? C plus, right? This is carbon plus and this is what? CH3. This is what? CH3. This is another CH3. Let me just expand each bond. Hope you remember what do you mean by hyperconjugation, right? What do you mean by hyperconjugation? It is the delocalization of carbon hydrogen sigma bond. Which all are carbon hydrogen? This is carbon hydrogen sigma bond. This is carbon hydrogen sigma bond. This is carbon hydrogen sigma bond with the adjacent carbon with an empty p orbital or unsaturation. Basically, carbocation contain a empty p orbital. So this p orbital can overlap. This p orbital can overlap with what? The adjacent all carbon hydrogen sigma bond. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 hyperconjugations are possible there. 9 overlapping delocalization is possible. More structures you are getting. What about secondary? If you come from tertiary to secondary, secondary carbocation I can draw like this. This is the secondary carbocation. These are the nearest carbon hydrogen sigma bonds, right? These are the nearest carbon hydrogen sigma bond, and carbocation carry an empty p orbital. So this p orbital can here overlap with adjacent 1, 2, 3, 4, 5, 6. 6 overlapping is possible. What about here? 9. What about here? 6. What about here? Third. Here? No. So as the number of hyperconjugation structure increases, their stability increases. So how you can able to explain why tertiary is more stable carbocation as per hyperconjugation? In tertiary carbocation, there is more number of delocalization is possible because on the carbocation on p orbital nearest there are many carbon hydrogen sigma bond. So many overlap is possible, many hyperconjugation structures are forming, it make more stability. So overall stability of the carbocation is tertiary, secondary, primary and methyl. You can explain with the help of either inductive effect or hyperconjugation. Clear all of you? Let's go for the next one. Using curved arrow, NCERT question. Using curved arrow notation. What is curved arrow notation? This one. Using curved arrow notation, show the intermediates form. What are intermediate? Whether it is cation, anion, free radical, etc. Let me take the first one, CH3. Okay, let me explain here itself. Carefully listen, all simple. See, CH3, SCH3. See, this bond actually connected to which all elements directly? Here carbon and here sulfur. Just to check whether it is same element or different element. Carbon, sulfur, of course different element. So there is a change in electronegativity. Can you say carbon or sulfur which is most electronegative element? Sulfur is more electronegative. So definitely both of that electron completely shifted to what? Carbon, sorry sulfur. You will get CH3 plus and SCH3 minus. You know, it undergo heterolytic cleavage. We get a cation and anion. So what is the thing you have to understand here? Which is more electronegative? That's it. Let me show you another example. This bond actually directly connected to carbon and carbon. See, both of the elements are same, but both side different species are there. One is CH3, one is Cn. So first element connected is same. So check the next element. Here it is connected to hydrogen. Here it is connected to nitrogen. Among hydrogen and nitrogen, which is more electronegative? Nitrogen is more electronegative. So we will get CH3 plus and Cn minus. Okay, what about this case, dear all? You can just pause the video, do the calculation. This bond actually connected to carbon and copper. You know, copper is a metal. Metals are electropositive, so they will donate. So what you will get? CH3 minus and Cu plus. Clear all of you? So all undergoing homolytic. Let me give you one more example as a D, my choice. Okay, CH3, what you will do there? Here both sides same species mean no doubt, right? Use what? Fish-hook arrow. This is normal arrow. Use fish-hook arrow representation. Give one electron to CH3. Give one electron to CH3. You will get CH3 dot, CH3 dot. Hope you remember what is this dot species, odd electron species we call free radicals. Clear all? Okay, next. Write the resonance structures of. This is common. Not a benzene compound, the first one. What is that? Acetate. What is acetate? CH3 COO minus. This is acetate structure. Lewis dot structure on the oxygen, you know, the lone pairs are there. You know, double bond oxygen 2 lone pair, single bond oxygen 3 lone pair. How to draw the resonance of this carbonate ion? Sorry, the ethanoate ion or acetate ion. So dear all, you know, what is mean by resonance? Mean movement of pi electron. So in order to move this pi electron, this lone pair become a bond and this bond becomes a lone pair. So how can we draw that structure? CH3 as it is. C. What happened? This side it becomes double bond, right? This side it become double bond and this lone pair already given. And negative charge get neutral, right? Because it's given lone pair mean positive, positive and negative get neutral. But this side what happened? Double bond becomes single bond. Already two lone pair is there. Now getting one more lone pair, gaining electron, it get negative charge. So overall, this thing just switch. Right? Overall, these two things switch. Check it all of you. So this is called resonance. How to do resonance actually? If there is a lone pair and a double bond nearest, lone pair become double bond become lone pair. That's it. Okay. Now what is this compound? C6H5NH2 aniline. What is aniline? Benzene with NH2. Let me draw fast, okay? After that, you pause the video and check the structure once again. This is aniline. Aniline nitrogen contain one lone pair. I already given you NH2 is an electron donating group. So it's a plus R effect group, right? They will give electrons to benzene ring. So this lone pair become a bond, the bond become a lone pair. So we can draw. And one more thing, careful dear all, while you drawing resonance structure, the arrow should be double-headed arrow because it's reversible. So these two bond, nothing happen. Here it is NH2 and nitrogen can get a plus charge because it's losing, and here it will get negative charge. Second step, this lone pair become a bond and bond become a lone pair, and we can get a structure double bond NH2 plus the new lone pair here. Second last, lone pair become bond becomes lone pair, we get double bond this side and negative charge is here and NH2 here, and final structure they will go back, lone pair back to the nitrogen. So here the double bond NH2 lone pair. Okay, so plus R effect is always same type, minus R effect is also the same type. So I think three structure we discussed today: phenol resonance structure, nitrobenzene, aniline. So keep write and practice the structures. Next one, write the IUPAC name for. Definitely they ask you question based on IUPAC. Hope you know very well about the IUPAC. Just pause the video and do your calculation first all. First question. First analyze is there any functional group or not. As per that, select a parent chain. You know, this is CO group on carbon, this is ketone, this is COOH, this is acid. You know that the priority order of functional group you may study it. Acid is the number 1 priority group. So number 1, number 2, number 3, number 4, number 5. And one more thing. Here ketone is a minor group. If ketone come as a major group, you will write the name of the or end with the compound name with on. But here it's a minor group because acid is there as a major group. If ketone come as a minor group, we will use the prefix what? Oxo, right? Oxo. So what we are writing? 4-oxo. Fourth position ketone. 4-oxo pentanoic acid. Right? 4-oxo-pentanoic acid or 4-oxo-pentan 1-oic acid we can write. So this is the name of the first compound. Second and third structure, please carefully listen all. Now, here, hope you can able to see chlorine is there, nitro is there, methyl is there. There is no major group. There is no major functional group here. Chlorine, nitro group are not major functional group. Keep in mind. Major functional groups are which all? Acid, carboxylic acid, sulfonic acid, cyanide, aldehyde, ketone, double bond, triple bond, alcohol, amine, aldehyde, ether. These all are what the main group. Halogens, alkyl groups, nitro group, these all are called the least priority groups. Okay, so here all are least priority group. Even this case you check nitro, chlorine, methyl, all are least priority group. There is no main group like OH. Correct. If all are least priority group, the rule is all of them should get least number. Such a way we have to number the benzene ring. If you start from on top 1, 2, 3, 4, I think this is better. See 1, 2, 4. 1, 2, 4 position are there. If you start from here 1, 2, 3, 4, it will be 1, 3, 4. It's wrong. It is bigger number. Yes. Now alphabetical order. You know this is chloro, this is nitro, this is methyl. So what we can able to say, the alphabetical order chlorine first, right? So we can start the name of the compound is 1-chloro. What is next? LMNO, right? Methyl first, then nitro group, right? So 1 chloro, 4 methyl, 2 nitrobenzene. Can you tell me the name of this compound if it is so? Where you can start numbering, dear all. Here if you start numbering from top, you will get 1, 2, 3, 4. 1, 3, 4 position groups are there. If you start from down, 1, 2, 3, 4, 1, 2, 4 position groups are there. This is the least number. Then alphabetical order. Where is chlorine? Second position. So its name is 2 chloro, 1 methyl, 2 chloro, 1 methyl, 4 nitrobenzene. Okay, so if all are least priority group means, which all are least priority group? Halogen, nitro, alkyl groups. If all are least priority group, all of them should get least number, such a way number in, then alphabetical order, write it. Chlorine first, then methyl, then nitro. Clear all? Next one. What is IUPAC name of this cyclic compound? You know this compound which is the main functional group OH. So we can place it number 1, 2, 3. Third position 2 methyl groups are there, right? What is this? CH3 group. So the name of the compound is 3,3-dimethyl. 3,3-dimethyl cyclohexane, right? Cyclohexane, or we can write cyclohexanol or cyclohexane-1-ol. 3,3-dimethyl cyclohexanol. Don't write benzene, okay? It's cyclohexane. What about this compound? Here main group is there, double bond. So double bond should get highest priority 1, 2, 3. Then alphabetical order, this is chloro, this is bromo. So bromine first. So we can write 3 bromo, 1 chloro, cyclohexene or cyclohexa-1-ene. One, there is no importance, so we can directly write cyclohexene. There are these kind of compounds while answering careful. Let me tell you this also. What do you mean by OMe? They are all Me stands for methyl group, okay? Me stands for methyl group. So OCH3 mean methoxy. OCH3 means what? Methoxy. Okay. Methoxy is there, chlorine is there, acid is there. No doubt acid is the first priority. So number 1 we can place it here. 1, 2, 3, 4. Alphabetical order, chlorine first, then methoxy. So what is the name of the compound we can suggest, dear all? 2 chloro, all of you say together. Sorry. 2 chloro, 4 methoxy. 2 chloro, 4 methoxy. What is benzene with the acid? We call benzoic acid. Correct or not? Benzoic acid. So what is the name, dear all? 2 chloro, 4 methoxy, benzoic acid. And check this chain, dear all. Is there any main functional group? Yes, OH is there. Dear all, basically short form if they given, condensed form if they given, please expand it. It's a track. Okay. Let me just expand the structure detail. That is CH3, CH. What is C2H5 mean? CH2, CH3. Okay. Another CH that also contain what? CH2, CH3 and another contain CH2OH. Okay, select the parent chain. I think most of you may take the straight chain as the parent chain. No. Here alcohol is the main group. Alcohol included a longest chain. You take it. You may take 1, 2, 3, 4. Dear all, there is another chain. 1, 2, 3, 4, 5. Yes, this is the parent chain. Okay, so this is what? This is which branch? Methyl branch. And what is CH3, CH2 branch? This is ethyl branch. Okay, clear all? So therefore, C2H5 some short form given, please expand. So this is 1, 2, 3, 4, 5. Ethyl or methyl, which will you write first? Alphabetical order, ethyl first, right? So where is ethyl present? Second. So the name of the compound is 2-ethyl. Where is methyl present? 2 position. So second position 2-methyl. Once again, dear all, let me check. 2-ethyl, 3-methyl, total 5 carbon. So pentane, 1-ol or pentanol can be right. 2-ethyl, 3-methyl, pentanol. Clear all? So when they given a condensed formula, there will be some trap. So please expand it. And functional group included longest chain. Please take it. Okay. Next one. Here they given all our NCERT question. Here they given the name of the compound. We have to write the structure. Carefully listen. Ortho-ethyl anisole, which mean ortho position. There is a ethyl group in anisole. What do you mean by anisole? First of all, that's compulsory to know. Dear all, anisole mean benzene with the OCH3. Benzene with the OCH3 group is called anisole or methoxybenzene. Which is the ortho position? These or this. So this one we can write ethyl group. What is ethyl group? CH2CH3, or we can write C2H5. So this is called orthoethyl anisole. What is anisole? Benzene with the OCH3. Next one, para-nitrobenzoic acid. So benzoic acid is the main group. What is benzoic acid? Benzene with the acid. You know, this is called the para position where there is a nitro group. Symbol, para-nitrobenzoic acid. I think this question we already did, right? Hope you remember the C question. 2,3-dibromo, 1-phenyl pentane. Pentane means 5 carbon. Second and third position 2 bromine, and first position there is a phenyl. I think we discussed this question before. Okay, I'm not concentrating on this one. We did this before in the one another question. Let's see the D question. All carefully listen on D question. 4 ethyl, 1 fluoro, 2 nitro, benzene. So benzene is there. Let us fix the species. 4 ethyl, first position fluorine, fourth position ethyl, C2H5 or CH2CH3, and second position nitro. Correct? Okay. 4 ethyl, 1 fluoro, 2 nitro, benzene. Clear all of you? Simple thing to write the structure. Okay, next one. What are the hybridization state of each carbon atom in the following compound? You know, hybridization is checking is very easy. Keep in mind. If a carbon is fully single bond connected carbon, its hybridization is sp3. If a carbon having one double bond connection, it's sp2. If a carbon having triple bond, that is sp. If a carbon having both side double bond, then also sp. Just keep in mind. Sorry. Now we can directly go for that. Okay, if the carbon all are single bond connected, sp3. One double bond only, sp2. One triple bond means sp. If both side double bond, that also sp. Let's check it. Here I will be right. This is CH2 double bond C double bond O, C. This carbon is having one double bond connection, therefore it is sp2. This carbon having both side double bond, therefore it is sp. Alright. What about this carbon? Let me write. This is CH3 CH double bond CH2. Check it all of you. And let me just write this also. What is CH3 twice CO mean? On CO, there are 2 CH3. That's the meaning, right? CO, you know, carbon oxygen always double bond, both side 2 CH3. What is here? CH2, double bond, CH. Careful about CN. You know, carbon, nitrogen are bonded through triple bond. Careful. How to answer? This carbon fully single bond, therefore it is sp3. This carbon having one double bond, therefore it is sp2. This carbon also having one double bond, it's also sp2. Simple. What about this carbon? Full single bond, sp3. This is full single bond, sp3. But this having a double bond, what is that? sp2. This is one double bond, sp2. This is having one double bond, sp2. But this carbon having a triple bond, therefore it is sp. So this way, carbon compounds we can easily understand the hybridization. Okay, then write the bond line formula of. What do you mean by bond line? Only use lines, bonds. What do you mean by isopropyl? You know, isopropyl group, you may study it like this. What is mean by isopropyl group, dear all? CH3, CH, CH3. This group is called what? Isopropyl with one alcohol. So how can you write its bond line formula? Total 3 carbon in the chain. So 1, 2, 3. 1, 2, 3. Second position there is an OH. This is the bond line formula. This is CH3, CHOH, CH3. What about 2,3-dimethyl butanol? Let me draw the shape first of all. What is 2,3-dimethyl butanol? Butanol means we know butanol, aldehyde, right? So one of them is aldehyde, CHO. Second and third position, 2-methyl group. So 2,3-dimethyl, right? This is the compound number, carbon number 1, 2, 3, 4. 2,3-dimethyl butanol. Let me write the valency here, CH. Okay, how to draw, dear all? In the main chain, 1, 2, 3, 4. 4 carbon. So let me draw fast. 1, 2, 3, 4. Okay. And the last carbon is already given C double bond OH. So we can write like this one. C double bond OH. Okay. Actually, there is a carbon. Actually, there is a carbon. Carbon not necessary to mention. Okay, if it fine. CHO is there. So On this second carbon you can see one CH3 is there, third carbon also one CH3 there. That's it. Okay, this is the bond line formula. What is heptane 4 on? Heptane means how many carbon? 7 carbon. 1, 2, 3, 4, 5, 6, 7. Heptane 4 on, fourth position ketone, right? This is the heptane 4 on compound. Can you tell me how to draw the bond line representation? Total 7 carbons are there. So let me write 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And in the 1, 2, 3, fourth position, 1, 2, 3, 4, fourth position there is a ketone. That's it. So in bond line formula, as I told you, carbon normal elements no need to mention as carbon separately, but some heteroatoms coming like oxygen, nitrogen and all, we have to specially mention that. Okay, hope it's clear. Write the IUPAC name of the following compound again. Dear all, first question is given. They given a benzene ring, right? They given a benzene ring. On the benzene ring, what you have? Here one CH2, here one CH2, here one CH3. So let me write CH2, CH2, CH3. Okay. Now carefully listen all. Okay, this is the first compound. Let me just expand each compound in this way, then we can start the name. Okay, this is what C. So this is what CH3, CH2, CH, on which one CH3, again one CH2, then Cn. Here see these all are what? Carbon. These all are carbon. We can write, I'm starting from left side, CH3, CH, on which CH3, then CH2, then fourth CH2, another CH, in which down one CH3, then another CH2, CH3. Here, you know, these all are what? Carbon, right? So I'm starting from here, CH3, CH2, C. On this C, there is one bromine and one chlorine, right? Continue the chain, CH2, 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 CH3. Okay. Last one, chlorine is already there. You know, these are our carbon. Chlorine connected to CH2, CH2, then CHO. Hope it's clear. What is the last one? Let me just expand. OH connected to CH2. On CH, there are 2 chlorine. Yes, this is the structure. Now let me tell you the name of each compound in detail. Dear all, carefully listen. In first question, this is a benzene ring, you know, it's a branch here. The main chain is this one. Main chain is this one. So this is 1, 2, 3. First position, there is a phenyl ring, right? Phenyl ring. On a chain, if benzene come as a branch, what we call phenyl. So one phenyl. So the name of the compound we can able to say 1 phenyl propane. Yes or no? 1 phenyl, 3 carbon, what we say? Propane. What about the second compound? Second compound we can able to say like this. Here cyanide is the main group. So 1, 2, 3, 4, 5. What we can able to say? You know, cyanide compounds we call it as what? Nitrile. Nitrile. So third position methyl, right? So it's called it as what? 3-methyl pentane nitrile. Why 3-methyl? Third position there is a methyl group, right? And total 5 carbon with what? Nitrile. Nitrile means what? Cyanide. Okay. So 3-methyl pentane nitrile. What about this case? There is no functional group. Only branches should get least number. I think this is the best 4, 5, 6, 7. So second and fifth position 2-methyl group. So 2, 5 dimethyl. 2, 5 dimethyl. 7 carbon what we can call heptane. Alright, and this question, the as a functional group, bromine is there. So let's start from here, 1, 2, 3, 4, 5, 6, 7. Third position bromine is there, third position chlorine is there. Alphabetical order bromine should come, you know. So let's start 3 bromo, 3 chloro, 3 bromo, 3 chloro, 7 carbon what we can call heptane. Clear all? Okay, next one. Here aldehyde, you know, CHO is called aldehyde. So main group is aldehyde here, and third position one chlorine is there. So the name was what? 3 chloro, 3 carbon aldehyde what we call propanol. 3 chloro propanol. What about here? Alcohol is the main group. So 1, 2, second position 2 chlorine is there. So what we can say? 2, 2 dichloro. 2,2-dichloroethanol, right? 2,2-dichloroethanol. Symbol, the nomenclature. Then, which of the following, one MCQ, which of the following carbocation is more stable? We already said the stability of carbocation is tertiary greater than, secondary greater than, primary greater than methyl. Dear all, option A is, let me just expand, okay. Option A is CCH3 thrice, then CH2 plus. What type carbocation is this? This is just a primary because the carbocation connected to only one carbon. So not option A. B is given CH3 thrice C plus. So on that C plus there are CH3, 3 CH3. Do you think it's tertiary? Yes, of course, because the carbocation connected to 3 carbon. This is tertiary. Tertiary is the most stable. So option B. And what about this one? This carbocation connected to only one carbon. This is primary. Here the carbocation connected to 2 carbon. This is secondary. The most stable carbocation is tertiary. That is option B. Clear all? Then write all structural. Now we are coming to isomerism part. Okay, they're all very important question. Write all structural isomers of molecular formula C3H6O. C3H6O, right? See, carefully listen. 3 carbon is there and with 1 oxygen. So we can confirm it's not an ester, it's not an acid because they contain 2 oxygen group. It can be an alcohol. You know, alcohol contain 1 oxygen. It can be an ether. Ether contain 1 oxygen. It can be an aldehyde. Aldehyde contain 1 oxygen. It can be a ketone also. Okay. So let me try with an aldehyde whether it is possible or not. The formula. 3 carbon. What is 3 carbon contain aldehyde? CH3, CH2, CHO. Propanol. 3 carbon contain aldehyde is what? Propanol. So check the formula correct or not. 1, 2, 3. Yes, 3 carbon. How many hydrogen? 3 plus 2, 5, 5 plus 1, 6 hydrogen and 1 oxygen. Perfect. This is an aldehyde. So what is this? What is this compound? Propanol. This is an aldehyde. Can you say aldehyde can show what type isomerism? What are the structural isomer you studied here all? You may study chain isomerism, position isomerism, functional isomerism, metamerism, maybe tautomerism also. So this aldehyde can show which isomerism? Functional isomer it can give. What is the functional isomer of aldehyde? Ketone. If there is an aldehyde, there will be a ketone with the same formula. What is the 3 carbon contained ketone dear all? That is CH3, CO, CH3. What is CH3, CO, CH3 is called propan 2-on or acetone. Check the formula. 1, 2, 3. 3 carbon, 3 plus 3. 6 hydrogen, 1 oxygen. So keep in mind all of you, if there is an aldehyde, its pair will be ketone. So if there is 3 carbon contain aldehyde mean there will be a 3 carbon. It's not for all, just starting from 3, okay. If there is a 3 carbon contain aldehyde mean there will be a 3 carbon contain ketone. So aldehyde ketone will show which isomerism? Functional isomerism. What do you mean by functional isomerism? Same molecular formula but different in functional group. See, one is aldehyde means one is ketone. Let me give you another pair. If they given a alcohol means its pair will be an ether. If they given a alcohol mean their pair will be an ether. One another, if they given a carboxylic acid mean its pair will be an ester. Please remember these 3 set. If they given a aldehyde, always majority, its functional isomer will be a ketone. If they given an alcohol means its pair will be an ether. If they given an acid mean there will be an ester. So these are the 2 isomers of this formula C3H6O. Next, write the structure of chain isomers of pentane. I think we already did this question. Pentane, what all the isomers dear all? N-pentane is there. N-pentane is there. 2-methyl butane is there and neopentane is there. What is neopentane? Neopentane is nothing but 2,3-dimethyl propane. 2,3-dimethyl propane. I think one another question for an explanation I think we already discussed. Just check that slide, okay. Next one. Pentane 2-on and pentane 3-on shows which isomerism? What is pentane 2-on? Second position there is a ketone, right? This is called a pentane 2-on. What is pentane 3-on? CH3 CH2. Third position there is a ketone. This is pentane 2-on and pentane 3-on. What type isomerism given by this? See, same formula. What is the difference? position of functional groups are different. Here second position, here third position. So what type isomerism is this? Positional isomerism, right? Positional isomerism. Same formula, different in the position of functional group is called positional isomerism. Next, N-pentane. What is N-pentane? All carbons in the straight chain. What is neopentane? Neopentane means 2,2-dimethyl propane. See, they're all same formula, but their carbon chains are different. What type isomerism? They can show chain isomerism. Okay, hydrocarbon basically shows chain isomerism. Same formula, different carbon chain. Another question, ethanol. What is ethanol? You know, ethanol is CH3, CH2OH. What is methoxymethane? Methoxy, CH3O, methoxymethane, methoxymethane. This is an ether. I already told you, alcohol and ether shows functional isomerism. What is the formula, dear all? 2 carbon, C2. How many hydrogen? 6 hydrogen and 1 oxygen, right? See the formula here, 2 carbon, C2. How many hydrogen? 6 hydrogen, X6, and there is 1 oxygen. See, alcohol and ether, if they given, what type isomerism is that? Functional isomerism. Functional isomerism. Same formula, but different functional group. Okay, next one, methoxypropane. What is methoxypropane? Prop means 3 carbon, right? 3 carbon. Methoxy mean OCH3. Methoxypropane. This is an ether, ROR. What is ethoxyethane? Ethoxy mean eth mean 2 carbon. Ethoxyethane, right? See, they are all ethoxyethane. What type isomer is this? You may study ether in which on ether oxygen, here left side propyl group, right? Here left side which branch, which chain? Propyl, but right side what you have? Methyl. But about in this case, here ethyl, even right side also what? Ethyl. You know, ether shows one isomerism, especially what we call metamerism. What we call metamerism. What do you mean by metamerism? It's actually a type of positional isomerism, right? Position actually different. But in ether, on oxygen, left, right group, you check it. If the groups are different, see same formula, both of these having same formula, but the groups are different. One propyl, one methyl, one ethyl, like that. So same formula, but different alkyl groups present left and right on the functional group, what we call metamerism. So this is metamerism. Then expand each of the following. This is see the bond line formula, right? Expand. Let me just expand this one. Let me draw the shape once again here. There is a hexagon, then a carbon. Let me draw the carbons. Let me place the carbon here. You know, dear all, these all meeting points and ending points, you know, carbon. You know, this carbon already 2 bonds are there. So remaining 2 what? Hydrogen. This carbon, see these all carbon are what? Which carbon? CH2, right? This is all are CH2. What about this carbon? Already 1, 2, 3 bond over, next one hydrogen. This carbon 1, 2, 3, fourth hydrogen. This carbon already 1 bond, so remaining 3 hydrogen. Here also remaining 3 hydrogen. So overall, each carbon valency should be what? 4. What about this one? They're all, these each places represent carbon, okay? This each place represent carbon. Carbon, 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 carbon. What is this carbon? CH, right? This is what? CH. Because this carbon already 3 bonds are there, 1 bond with a hydrogen. Then triple bond C, then CH2, then CH, on which OH, then CH3. How can we expand this one? Each bond expanded. So this is CH means CH, triple bond C, CH2, CH, OH, CH3. See, expand each and every bond. Okay, so bond line formula to expand, expanded to bond line, condensed, anything can be expect. Now, which bond is more polar in the following pair of molecule? Which bond is more polar? They are all polarity. Basically, I told you polarity means charge separation. If it want to be more polar, there should be a large difference in their electronegativity. Let's see. This bond is CH3. Okay, let me explain here itself. Carefully listen on. See the first question. This bond is actually connected to carbon and hydrogen, but here it's connected to carbon and bromine. I told you in one case, carbon, hydrogen, there is no large difference in electronegativity, but carbon and bromine, there is a large difference in electronegativity. Bromine is more electronegative. So, bromine take electron, it get negative charge, it get positive charge. So, this is what? More polar. So what we want to identify in polarity, dear all, which check the carbon bond and it's connected to which all element, where more difference in electronegativity, where more polarity. Let me show you this example. It is given CH3NH2, the pair is given CH3OH. What is the basic difference? In first question, carbon connected to nitrogen. Here carbon connected to oxygen. Where there is a large difference. See, carbon common, right? Here nitrogen, here oxygen. Check. Nitrogen or oxygen is more electronegative. Nitrogen, oxygen. See the right side. Right side of the periodic table, in across a period, electronegativity increases. Oxygen is the most electronegative element. So, this will be what? Most polar. Okay, most polar. What about this case? It's connected to CH3OH and CH3SH. What is the basic difference here? Here carbon connected to oxygen, here carbon connected to sulfur. So difference is oxygen and sulfur. Oxygen and sulfur, where they located? Oxygen, sulfur, they located same group. You know, down the group electronegativity decreases. So oxygen is the most electronegative element. So therefore this is what? More polar. So when checking the polarity, identify where there is a large difference in electronegativity, where more polarity. Yes, which type of isomerism is shown by butane and isobutane? What is butane? Butane means 4 carbon in a straight chain. Yes, dear all, this is butane. What is isobutane? Isobutane, you know, this is called what? Isopropyl with one more carbon, what we call isobutane. What is this isomerism? Same formula, but their carbon chains are different. Which isomerism can be suggested, dear all? Chain isomerism. Clear all of you? Simple question. Write the structural formula of the following, and let me draw the shape. 2,2,3 trimethyl pentane. Pentane means how many carbon? 5 carbon. Second position 2, 2. So 2, second position 2, third position all methyl groups. So CH3, 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 and place the group, the valency CH3, CH, CH2, CH3. So always write parent chain first, fix the groups, then fill the valency. What about this one? 4 chloro, 3 methyl bute, 2 ene, 1 ol. Bute. Bute means how many carbon? 4 carbon. 4 chloro. Okay, bute, right? Only 4 carbon, right? This 5 carbon. Sorry. So this 4 carbon. 4 chloro. So fourth position there is a chlorine. Third position there is a methyl. Third position there is a methyl. Second position there is an alkene. Second position alkene. First position there is a alcohol. Yes, already filled. Now valency. CH2, CH, CH2, Cl. Check all of you. This is number 1 carbon. 1, 2, 3, 4. See, 4 chloro, 3 methyl, bute, 2 ene, 1 ol. Yes. Check the valency. Okay. I'm just writing so fast. So please check the valency, correct or not. You hope you know the valency. I think it's correct. Okay. Yes. Okay. So finally, thank you all. And here is a most important question discussion for your organic chapter. I think most of the questions we discussed here. Hope it's enjoyed and clear the doubts, and please practice the question. If you have any doubt in any question, please pause the video, watch the explanation and check all the valency of the carbons are correct here or not. And hope it's clear all the concepts, all the effects, and explain the stability of carbocation, nucleophile, electrophile differences, homolytic, heterolytic fission, IUPAC nomenclature, bond line, expanded, condensed, all formulas, everything. So thank you very much all of you. Thank you once again, and let's discuss one other chapters also in the upcoming video. So thank you all. Goodbye.